Hello all. Today we'll discuss the details of Newton rings experiment and see the condition for the formation of bright and dark ring and derive the expression for the radius of bright and dark ring. So as we know in Newton rings experiment, we used to keep a plano-convex lens over a plain glass plate. Between the plano-convex lens and plain glass plate, a wedge-shaped thin film form. So, in general, in Newton rings experiment, the radius of curvature to be much greater than t. Here, the parameter r is the radius of mth bright or nth dark ring. It can be anything, and t is the thickness of thin film at which the r radius bright or dark ring is located. Okay, if this distance is, we know this distance is capital R and this distance is small t, so this must be capital R minus t. So we know for a thin film of uniform thickness, the path difference between two rays that are getting reflected from the top surface of thin film and at the bottom surface is 2 mu t cos r plus lambda by 2, where lambda is the wavelength of incident light and mu is the refractive index and r is the angle of refraction. So in our case, the thin film is made of air, so refractive index must be 1, and since rays are incidenting normal to the plane of plano-convex lens, so the angle of incidence is 0, so angle of refraction must be also 0. So substituting these two into equation 1 gives me the path difference between the two rays is 2t plus lambda by 2, and we know using the Pythagoras theorem we can write r as r minus t the whole square plus r squared, this side squared plus this side squared. And as I told you, this t, if t is less, then t squared will be lesser than t, so this can be omitted and this can be r squared and both sides of this equation can be cancelled. So this equation 4 is reduced to 2rt is equal to r squared. So altering this, we get the thickness of thin film at which we have r radius bright and dark ring. So substituting this t into equation 2 gives me this expression, equation number 7. And so looking for the bright ring means what is the path difference for the bright ring. So as we know, for the bright ring formation, the path difference should be integral multiple of incident light wavelength. So substituting the path difference expression into this equation gives this, and altering this equation gives me the radius of mth bright ring in terms of the known parameter radius of curvature lambda and order of bright ring. Okay, so next, for the dark ring, this path difference should be half integral multiple of incident wavelength, that is 2n plus 1 lambda by 2, and putting the expression for delta L from the equation 7 gives me this equation, and altering this equation gives me the radius of nth dark ring is equal to square root of n lambda of r. Okay, here you can see the radius of nth dark ring is going like square root of n. So as we increase the distance from the center, the radius, the rings are more crowded. So in addition to this, if you know the two different radius of mth and nth dark ring, then we can find the radius of curvature by using this formula. Subtracting equation 11 from 10 gives me this expression, and here if you know lambda, put that in the denominator and keep the unknown parameter on the left hand side of others left hand side, you get radius of curvature of the lens. And if you know r and if you want lambda, you can find the lambda using equation 13. That's all. Thank you.